class. Today I'm going to be going over the final exam review. The review and the key have been posted on our class website, but I want to take some time to go over the problems individually just to make sure we are all on the same page. So this video is going to cover the true or false section. So, true or false? A vertical line through the point 2, -6 is y equals 2. Okay, so one thing we want to use is all the tools in our toolbox. So a great place to start would be to envision this point in your mind. We have where x is 2, y is -6. We'll just pretend we got there. Right, so here's our point where x is 2 and y is -6. And it says that a vertical line through that point is y equals 2. Well, let's go ahead and graph the line y equals 2. Where's y2? Right here. So this right here is the line y equals 2. That means that this can't be the line y equals 2, right? This is the line where x equals 2. Okay? So this statement is false. Why don't we practice correcting it? There's two different ways to correct it because we have two things that were wrong here. Vertical line, y equals 2. Okay? So we could say a horizontal line through 2, -6 is, will that be here where y equals -6? Or the simpler way to change it would be that a vertical line through the point 2, -6 is x equals 2. Okay? So there's two ways because there were two things that could be changed to correct this true-false statement. Okay, so you do whichever one you feel best about. When it comes to this true or false, I would definitely, they are worth less points. I would take a deep breath, do the rest of the exam, and come back to these so you can take some time and think. Okay, what makes this a false statement? Next, the equation x to the 4th minus 5x cubed plus 2x plus 1 equals 0 has at most 3 possible solutions. Okay, so let's think about that. If I have a linear equation, how many possible solutions for x is there going to be? There's going to be 1 possible solution. Let me write that better. Okay, if I have a quadratic function, how many possible solutions for this can I have, right? Remember, we unfoil these, we pull these apart. This is going to have 2 most possible solutions. At most 2 possible solutions. Now, if you think back to chapter 11, where we talked about working with polynomials, there's a rule that states the number of solutions to, when we set a polynomial equal to 0, the possible number of solutions equals its highest degree. For example, this linear equation over here, this is a degree 1, so it can have at most 1 possible solution. Here we have a degree 2, so it can have at most 2 possible solutions. So this equation, since it's a 4th degree equation, has at most 4 possible solutions. So this is false, and we could correct it by replacing the 3 with a 4. The next, true or false? The range of the function f of x equals x squared plus 2 is all real numbers. So let's go ahead and sketch this out. Remember, the range is all possible y values that this could take on. So we're going to sketch our lovely, and like I said, this is a rough sketch. You don't have to graph it perfectly, but I know if x is 0, I'm going to have y is 2, so it's going to look something like this. And it's not shifted to the left or the right because it doesn't have a constant in the parentheses with this x. Okay, so here we go. So this is where y is 2. What's the range of this? What possible values could it take on? Well, our range here goes from 2 all the way to positive infinity. And our domain, right, the domain of all quadratic functions goes from negative infinity to positive infinity. So there's two things we could change. There's two ways we could rewrite this. So let's go ahead and do that. So first, we could say the range of f of x is, instead of all real numbers, we now know the range is 2 to infinity. Or I could change the word range to domain, because the domain of f of x is all real numbers, like it said in the statement. So correct these to make them a true statement. Don't just negate them. Don't just say the range is not all real numbers. Tell me what the range is. Next, the solution set of the absolute value of x is less than 7 is negative infinity to 7. So remember, the absolute value takes any number and makes it positive. Why? Because we're measuring distance on the number line. So let's draw ourselves a nice little number line. Is that 7? Okay. So the solution set of the absolute value of x being less than 7 is negative infinity, comma 7. Okay, so that's saying my solution set goes from 7, open dot, right? 7's not included, that's why we have parentheses, all the way to infinity. Okay, but the equation needs to be that the absolute value of x is less than 7. Is the absolute value of negative 8 less than 7? No. How about the absolute value of negative 7? No. How about the absolute value of negative 6? Yes. Okay. So we would have our solution set to go from negative 7 all the way to positive 7 without our endpoints included. This is because all the values within this green range that I have sketched right here have an absolute value less than 7, right? Remember, we're measuring distance from the number line, distance from our origin, which is 0. So it has to be less than 7. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, this is our solution set. So I could replace this with negative 7, comma 7. That's our solution set. So this statement was false. I'm sure you gathered that most of these are false already, okay? On the exam, they're all going to be false. And you guys have to tell me why they're false, okay? So let's take a look at one more. The domain of the square root of x minus 2 is 2, comma, infinity. So we need to sketch it out. Okay, if I have the absolute value of 2, if I'm trying to find a couple points on this, remember our graphing rules, we know this is going to be shifted to the right, but let's plug in a value so we can see that. If x is 2, then I have the square root of 2 minus 2, which is 0. So when x is 2, y is 0. And if I have when x is 3, that's the square root of 3 minus 2, which is the square root of 1, which is 1. So it's going to look like this. Remember, they look like half a parabola flipped over. I always did the I'm a little teapot arm in class. Okay, so what's the domain of this? The domain of this goes from 2 to infinity. Okay, that's our domain. It's all possible x values. And our range goes from 0 to infinity. Well, gosh darn it, this is true. This is a true statement. True or false? This is a one-to-one function. You know what I would do? Sketch it out. Remember when I talk about the refrigerator? Here I have 1 going to 2, 4 going to 5, 3 going to 6, and 9 going to 6. So remember, if I push 3, I get a 6. If I push 9, I get a 6. This vending machine does work. So this is a function. The question is it a one-to-one function? Okay? Remember, one-to-one functions, each x has exactly 1 y, and each y has exactly 1 x. Okay? Because I have 3 and 9 going to 6, this is not a one-to-one function. Remember, one-to-one functions have to have inverses. And if I did this function the opposite way, so I had 6 going to 3 and 9, would this vending machine work? No, this vending machine would not work. Okay, so we can't find its inverse because this is not a one-to-one function. So this is false, and you could correct this by saying this is a, just get rid of the word one-to-one, right? This is a function, and that's true. So just continue to use the tools that we have in our mathematical toolbox. We were building them up all semester. Next, f of x equals x to the 9th minus 5x to the 4th plus 87 can have up to 9 real zeros. Well, this is really similar to problem 2, okay? Problem 2, where it has at most 3 possible solutions. When we're asking for zeros, we want to set this equal to 0 and factor it and pull it apart. Remember, the number of zeros something that can have is its highest degree. So this is a true statement. F of x can have up to 9 real zeros.